Good morning, I'm Bill Murray with IADD, and today I'm here with LODA Mud Motor Bearings. This is part of the IADD Mud Motor Technology Series in anticipation of the Mud Motor Forum. Let me introduce you to Mike Speckert and Majid Del Passan. Together they have over 5 decades of experience developing technology and products for the mud motor industry. Mike, you mentioned cloth membrane during your earlier discussion. Can you explain to some of the viewers who are not familiar with the cloth technology what it is and how you make bearings with it?
So I mentioned that the cloth membrane coatings have been used in the industry for 30 plus years, and I was part of the team that developed this technology some 30 plus years ago. And during most of that time, this has been the premium performance product as it applies to a mud motor bearing. The real key attribute to the technology was the fact that you could take a tungsten carbide powder and fabricate a flexible membrane and wrap that around pretty complex surfaces, a cylinder, for example, in this case. And the fact that it was highly engineerable, meaning that we could change the chemistry of the membrane, we could modify the particles to improve particle packing density, which would improve the hardness and wear performance of the product. And we've continued to push the performance envelope of this product over the last 30 plus years, and with LODA Mud Motor Bearings we've done that again by modifying the particle sizes and changing some of the chemistry to improve the wear performance of the product. But still recognizing that there is a performance gap between the matrix cloth-based materials and the tungsten carbide tile bearing, and that was the motivation for introducing our LODA tile bearing.
Okay, that's interesting. I could see also where the cloth will allow you to apply it to IDs much smaller than some of the other weld-on, spray-on, or pure tile applications.
A key part of our technology relates to the fact that we perform this process inside a vacuum furnace where there are no oxides, there are no inclusion of any outside particles. It's not like a welding or torching the body. Once the process is completed and the tiles are fused into the substrate, then we can actually take the substrate and heat treat it back to the properties that the customers are asking for, typically the yield and strengths that they're looking for. So we really have differentiated ourselves because of that process, because people who make these tile bearings with processes like welding or torching it, they don't have a control on what the substrate properties are going to look like. And a lot of times we've seen problems with that, with the structure.
So this is a combination of the tiles and the liquid metal matrix infiltration in between them, holding them in place. So what kind of advantages do you think that brings to the technology versus either a pure tile bearing or a pure matrix bearing?
The focus, recognizing some of the inherent issues that accompany a tile bearing, namely erosion between the tiles, being able to take advantage of our background and particle packing knowledge and modeling and things like that, we've been able to apply that technology to the carbide tile bearing. The result is we've got a very dense carbide loading between the tiles. So erosion is no longer an issue with the carbide tile bearing.
That's got to be very important in today's business, where a lot of the operators running motors, especially with rotary steerables, are really concerned about the bypass amount. Now that you have the wear resistance and the erosion resistance of the matrix coating between the tiles, this should offer the best of both: the wear resistance of the solid carbide and the erosion and reduced bypass loss of the matrix bearing. Yeah. Sounds like y'all got a real winner here.
Absolutely. I think the other point that I'd like to mention is that we know that one solution doesn't really fit all. We think that with offering both tile bearings as well as the basic matrix bearings, we can actually hit, depending on people's maintenance interval or their requirements for the cost of the tool that they want to use, we can actually address them differently. So this not only allows us to offer different technology for different solution, but also helps us offer different product at different price point for the same application.
You're a one-stop shop for the motor industry.
Our wear solutions are customizable for the customer's needs. In fact, you know, we talk about two distinctly different coating technologies, but we have some applications where we can combine both of them together on the same bearing. So we can apply the carbide tiles where they're most needed and the matrix membrane types of coatings in other areas where maybe tiles are not needed. So so we work closely with our customer and we listen to their needs and we try to come up with customizable solutions. So we're not an off-the-shelf seller of mud motor bearings. These are fully customizable, and because they're made here locally, we're able to turnkey these bearings quicker than our competitors who rely on supply chains from overseas.
I think it's very interesting. I think it's should be really good at addressing the mud motor's needs. I'm especially interested in where you can vary the location of the tiles. You can concentrate them on the ends. You can vary the orientation to suit your customer's specific needs and his application. That's really differentiating technology. That's great. I've seen y'all got a lot of equipment out back and technology to help facilitate that. It's quite an impressive endeavor. Well, I'd like to thank you both for taking the time to explain the technology in LODA Mud Motor Bearings to the IEDD, and everybody have a good day.
Thank
All
you.
right, thank you.